Hello again and welcome back. I try to keep the videos short, under 12. I saw we were at 12 minutes, so I stopped it. We don't have a couple more things to go in section 1 2. With the domain and range of the toolkit functions. And I'm glad this is on a new video because the toolkit functions, I rushed them at the end. F of x equals some kind of number, a. I'll make it a number, 3. And that's called the constant one. And it looks like this. 3, did I say? Domain is all the reals. Range is 3. Then that's the constant toolkit function. Then the next toolkit function. Incidentally, these are called toolkits because they're common, and you can take. If you know these, you can take them and like multiply by constants and what have you. But this is called the constant function, f of x equals x. It's just a 45-degree line through the origin. Here's 1, 1, here's 2, 2. You know, if I go to 10, we're going to be up to 10. If I go to negative 4 on x. And, so the domain is all the reals, and the range is also all the reals. By the way, any polynomial function, this is true. For example, the next one is the quadratic function. F of x equals x squared. F of x equals x squared looks like this. The domain is all the reals. It's a polynomial. Domain, all the reals. Range, well the range, this is never negative. F of x greater than 0. Whoop, greater than equal to 0. The tertiary, the cubic function. This is called quadratic. And then the cubic function, it will be here. F of x equals x cubed. Here's a picture of it. Looks like so. The domain, all the reals. It's a polynomial function. You can put any x in you want. The range is also all the reals. Domain and range, all the reals for the cubic function. Then we go to what is next? Radical, rational. Reciprocal function. There we go. Reciprocal function. Reciprocal function looks like this. F of x equals 1 over x. That's the rule for it. These are the domain is all the reals except x equals 0. You cannot put a 0 in there. You can't divide by 0. So then the range, it turns out, when you put all those things in, the range is also all the reals. That's the range. The range is also all the reals except f of x equals 0, except for 0 for that. It'll never hit this line, it'll never hit that line. That's all we're saying. Then square root function. We met other others. Yeah. Square root function looks like this. F of x equals square root of x. That's what the rule is. And the domain is all the reals except the negatives. You can't put a negative in there. X greater than or equal to 0. All the reals, x greater than or equal to 0. The range is the exact same thing. All the reals, f of x greater than or equal to 0. Will never be in any of these 3 quadrants. This particular function will never be in any of those 3 quadrants. Cube root, one more. Cube root function looks like this. Something like it. Sorry about it. Something like that. It looks like that. The function itself, the rule is x cubed. Cube root of x. And then the domain would be, well, you can put anything in there. You take the cube root of a negative number. The cube root of negative 8 is negative 2. So the domain is all the reals. And the range even though this flats out, it doesn't necessarily look like it. We'll take on all the reals. It'll take on every value up and down. So the range is also all the reals. Cube root. So those are your toolkit functions. And just, in looking at one reason we wanted to review the toolkit functions, the other we want to talk about domain and range. So, so here we go. One more thing, one more kind of function. It's called a piecewise function, in which you split up the domain. Piecewise. The domain is intervaled, it's split up. Domain is specified over intervals. How's that? Specified over certain intervals. The domain is specified over certain intervals. I should just make one up, I guess. Oh, here we go. And it looks like this. F of x equals some kind of formula. By the way, we use a bracket here to do this. Formula for some domain. And then there'll be another formula for another domain. And this could be a lot of them. 2 is enough. That right now it's piecemeal. And we could have 3. I'll tell you what, let's do an example with 3 and then we'll stop this. Yeah. This is straight from the book. No, not quite. It might be straight from the book. Okay. F of x equals x squared. X squared. Sorry, let me draw that better. I try to stay. F of x equals x squared if x is less than 1. F of x equals 3 if x is 1, 2. I think. Yeah. And x greater than 2. Yeah, something like that. One of these. This one, yeah. Oh, and it's x. So here we go. I'm going to draw each one of those functions separately. X squared. 3. X. Okay, I just drew them separately. Those are the first function, the second function, and the third function on 3 different things. But now, on 3 different graphs. Now we want to put it on the same graph. So what we're going to do, I'll just erase all this stuff and put it over here real big so you can see. What do we got to go to? 1. There's 1. We'll go to 0, -1, -2, 3. And then to 2. There's 2. And then over 2. So there, I'm just putting out the x. That's an x-axis, and then x squared. Okay, x squared. This one right here, it just goes, down, comes back up, and it stops. Right there. And as a matter of fact, there'll be an open circle there because we do not want to include 1. And then from 1 to, I should have it further. 1 to 2, it's x equals 1, 2, 3. Closed circle. Boom. It's closed. Yep, another closed circle. And then from 2 on, open circle. This is the point 2, 2, by the way. That's the point 2, 2. From 2 on, it looks like that. Forever and ever. So there you go. It's a piecemeal, meaning we put things together. All we're saying is this function takes on the x squared when it's less than 1. It takes on 3 in between 1 and 2, inclusive. And it takes on the function f at x equals x for everything greater than 2. That's it. Hey, that's section 1, 2 in a nutshell. Sorry I had to do 2 different... Wow, this is long too. Sorry I had to do 2 different videos. 1, 3 is coming soon.